Hey guys, I just wanted to go over this extra practice for the Punnett squares real quick. So the first section is just focusing on vocabulary. So if you look at the words, it tells you to define it, like in the textbook definition. Then it says to define it in your own words. So you're going to kind of put a description of what you think it is right here. And then how you will remember this. So this is just saying like we talked about in school, how homo means same. So you might write over here, you say homo equals same. So things like that. So you'll fill out this section for vocabulary. The next little part right here is asking you to define or describe the different laws of inheritance, and you already have notes on that. And then this part is the guided practice that we are going to do together. So the first section is asking you to just basically fill out these Punnett squares and then write the genotypic and phenotypic ratios. And it tells us for the genotypic ratio, use dominant to recessive, or excuse me, use homozygous to heterozygous, and for the phenotypic ratio, we're using dominant to recessive. So all we have to do here is fill out each of these Punnett squares. And if we remember about Punnett squares, we know that these right here represent parent 1, and this second section represents parent 2. And so these are the possible gametes that they are going to be giving through fertilization. So the top parent, the parent 1, might be the father producing sperm, and parent 2 might be the parent producing egg. So each of these inside possibilities shows us the possibilities through fertilization. So if we take a dominant sperm and a dominant egg, we will have a homozygous dominant diploid zygote, which is the first cell of a new organism. So each of these inside boxes represents one possible outcome between those two parents. And the way that we figure out these boxes was we're taking down the parent 1 allele, so we're bringing that dominant B down, and we're bringing over the recessive B from parent 2. So for each of these boxes, we're just bringing one letter down, or one allele down, and one allele over. So what we see here for a phenotypic ratio, remember the law of dominant states that even if there's only one dominant allele, it's going to show the dominant phenotype. So each one of these is actually going to show the dominant phenotype because it has at least one dominant allele. So there are 4 dominant possibilities and no recessive possibilities, because remember, if we needed recessive, we would have to have homozygous recessive to show that phenotype. And we don't see that at all, so there's a 0% chance of having that recessive phenotype. Now it wants us to say homozygous to heterozygous. Remember, homo means same, hetero means different. So we see homozygous 2 times and heterozygous 2 times. So that is a 2 to 2 ratio or a 1 to 1 ratio. The next section, we have homozygous dominant for parent 1 and homozygous dominant for parent 2. And so if we're bringing one allele down and one allele over for each of these possibilities, all of the offspring are going to be homozygous dominant, which means that we're still going to have 4 to 0 for our ratio of dominant to recessive, because remember, recessive, we're looking for that homozygous recessive, and we don't see that at all. For the genotypic ratio, we're wanting homozygous to heterozygous, and because all 4 of these possibilities are homozygous, that is a 4 homozygous to 0 heterozygous genotypic ratio. For our third one, we have parent 1 is homozygous recessive, parent 2 is heterozygous. And so when we fill out our Punnett square, we will get heterozygous in the top left, heterozygous in the top right, homozygous recessive in the bottom left, and in the bottom right. So when we're looking at our phenotypic ratio, we know that we're going to get a dominant phenotype in these 2 right here, but we'll get a recessive phenotype in these 2 possibilities. So here's a 2 to 2 or a 1 to 1 phenotypic ratio. Whereas our genotypic ratio, that will be 2 heterozygous to 2 homozygous. That's a 1-to-1 as well. So if we look at our next section, we have 2 homozygous recessive parents coming together, which means that each of these inside boxes for the offspring is going to be homozygous recessive, which means that there will be 0 dominant offspring, and there's a 100% chance for a 4 out of 4 for recessive offspring. And then if we look at genotypic, remember we're going for homozygous first, and there's 4 homozygous compared to 0 heterozygous alleles here. Right here we have a heterozygous parent pairing with another heterozygous parent. So that means that the top left box will be homozygous dominant, top right will be heterozygous, bottom left will be heterozygous, and bottom right will be homozygous recessive. This means that 3 of the 4 times are going to be dominant. So it's a 3-to-1 ratio because we only see 1 homozygous recessive for a recessive phenotype. However, the genotype, we have this is homozygous and this is homozygous, even though we have a dominant and a recessive variation. So that is a 1-to-1 heterozygous ratio. This is the last one we'll do together on this section. We have heterozygous and homozygous dominant. So in our top left, we will have homozygous dominant, top right is heterozygous, bottom left is homozygous dominant, and bottom right is also heterozygous. Your phenotypic ratio, you're going to have 4 dominant to 0 recessive, because remember recessive, we're looking for homozygous recessive. And your genotypic ratio, you will have 2 homozygous to 2 heterozygous, or a 1-to-1 ratio. Let's skip over to our next section in our guided practice. It says, let's say that in seals, the gene for length of whiskers has 2 alleles. The dominant allele W codes for long whiskers, and the recessive allele for lowercase w codes for short whiskers. What's the probability of producing offspring that will have short whiskers from a cross of 2 long whiskered seals, one that is homozygous dominant and one that is heterozygous? So we know that homozygous dominant, if we're working on parent 1, has 2 dominant alleles, because homo means same and dominant means we have these capital dominant alleles. Heterozygous, however, means 2 different alleles, so we'll have a dominant and a recessive allele. We bring one parent allele down, the other parent allele over, just as we did in our previous section. And if we remember that short is recessive and long is dominant, and we look at our possibilities, and according to the law of dominance, if it has even 1 dominant allele, it's going to show the dominant phenotype, then we see that we will have 4 out of 4 with long whiskers, which is 100% chance, and a 0% chance of short whiskers. B says, if one seal is heterozygous for long whiskers and the other is short whiskered, what's the probability that the offspring will have short whiskers? So it says that heterozygous, so that's 2 different alleles, and it tells us that the other one is short whisker, but it doesn't tell us whether he's dominant or recessive. And that's when we have to go back to our key of the traits. So we know that long is dominant and short is recessive. So if he is showing a recessive phenotype, then we know that his genotype has to be homozygous recessive. We will bring these alleles down and over just as we did in the previous section. And when we get to the end, we see 2 homozygous allele pairings and 2 heterozygous allele pairings. These heterozygous allele pairings have at least 1 dominant allele, so they will show the dominant phenotype, whereas our homozygous recessive allele pairings do not have any dominant allele, so they will show the recessive phenotype of short whiskers. Therefore, we have a 50% chance of long whiskered offspring and a 50% chance of short whiskered offspring. The next one says, in purple people eaters, 1 horn, H, is dominant and no horns, or recessive allele, is recessive. Complete the Punnett square to show a cross of 2 hybrid purple people eaters. Summarize the genotypes and phenotypes of the possible offspring. So when we see this word hybrid, hybrid is synonymous with heterozygous. So this means that we will have parents with two different alleles, one dominant allele, one recessive allele. So in our top left box, we'll have homozygous dominant. Top right and bottom left, we will have heterozygous, and bottom right will have homozygous recessive. This means that we will have each of those things show up in the possible genotypes. So all three possible allele pairings are shown up in this section right here. And then for our possible phenotypes, we know that it could be one horn or no horns. And if we wanted to put a percent with this, we know that one horn was dominant, and we see that 3 of the 4 times, so that would be 75% chance. Whereas no horns is a recessive trait, which would have to have homozygous recessive for the genotype, which only happens 1 out of the 4 times, or 25%. This section is what you are to complete on your own. These questions do have to be answered accurately in order to receive credit. So I just want to walk you through how you would approach one of these. I'm not going to give you the answers, but I do want to show you what's going on with this. So just to make sure that you are on the right track, it says in rabbits, black fur is dominant over white fur. So just to get you started, it might actually be helpful for you to say, to make a key. So we have black equals dominant and white is recessive. So you can make your own little key right here, and that'll help you keep all your information straight as you work this problem. It wants us to show a cross of a heterozygous black male with a homozygous white female. So when you're setting this up, we remember that hetero equals different, and homo equals same. So looking at these two things, if we have a heterozygous black male, we know that those alleles are going to be different, as in one dominant and one recessive. Whereas the homozygous white female, homo means same, and if she is white, that's going to be a recessive allele. So we know that she will have to have 2 recessive alleles for her genotype. You will sort all of this out, and also it asks for the parent alleles right here, so we know that one is heterozygous and the other one is homozygous recessive. Once you have filled out your Punnett square, you will look at the genotypic and phenotypic ratio, and it tells you up here for the genotypic, you'll say homozygous to heterozygous, and for the phenotypic ratio, you're still using dominant to recessive, just as we did in the sections above. Just to go over some things for the next few places, just to kind of make sure that we're on the right track. So we're going to make another key again for number 2. Tall is dominant, so tall equals dominant, and short would have to be recessive. And it says show the cross between a homozygous short plant and a homozygous tall plant. So remember that homo means same. So if we have homozygous tall, that's the same alleles for tall, which would mean 2 dominant alleles. And homozygous short would mean the same alleles for short, which would be 2 recessive alleles. So you'll put one parent on one side of the Punnett square, the other parent on the other side of the Punnett square, and you'll fill out your information just as we have before. This paper, if you are a traditional student, is due back on Wednesday, the 30th. So make sure that you get all this finished, completed, and that you have your quiz signed and returned by Wednesday the 30th. If you have any questions, please let me know.